This is second question of chapter 13, construction of quadrilateral. This is type 2. It is a construction of a quadrilateral when three sides and two diagonals are given. In the previous question, you have learned how to construct a quadrilateral when four sides and one diagonal are given. Now in second type, out of four sides, you will be given only three sides and both are diagonals, two diagonals. So S, D, D. 3S stand for three sides and 2D stand for two diagonals. Let's say PQRS is a quadrilateral, then for this quadrilateral QS and PR are two diagonals. So out of four sides, we will be given any three sides and the length of both the diagonals also will be given. So for this type of question, let's straight away to one of the questions. Here is the question. Construct a quadrilateral EFGH given that EF length is 6.2 cm, FG length is 4 cm, EZ length 5 cm, EH is 4 cm and FH is 7.3 cm. So before we start solution or step of construction, draw a rough diagram of quadrilateral EFGH without measurement. So we write a quadrilateral and name it EFGH. Then write the given length. The length of EF is given to be 6.2. We write 6.2. Then FG 4 cm, EH 4 cm, EZ 5 cm. This is diagonal, and another diagonal FH is 7.3. So for this type of construction, that means when two diagonals and three sides are given, the first step we have to draw the sides, which is the middle of the third size. You can see here three sides EF, FG and EH are given. So out of this given three sides, I think EF is the size to be drawn in the first step. So let's go to the solution. Step of construction. The first step is EF is equal to 6.2 cm is drawn, which is base in this quadrilateral. So now we draw EF, which is 6.2 cm long. So use your scale, 6.2. Start from 0 and continue till 6, 6.1, 6.2. You can see this is a line, this longer line is for 6, and after that you can see small division. So the first one after 6, it is for 6.1, then for 6.2, for 6.3, for 6.4, for 6.5, like that. We have drawn EF. Let's name this as EF. Then second step, you have many options for second step. Now we have EF. After this, your second step can be for EZ, for EFH, or if you take if you start from E, it can be for EZ or EH. So out of these many options, we have taken for the size FH, which is a diagonal of 7.3 cm long. So second step is with F as center and radius 7.5 cm and arc is drawn. Why we take radius as 7.3 cm? We are to draw for size FH, which is 7.3 cm long. So let's do this second step. The radius is now 7.3. So 7.3. Yeah, exactly. It is 7.3. Taking F as center, we draw an arc whose length is 7.3. Since we have drawn an arc for size or for diagonal FH, now the next step, the size we're going to draw will be for EH, because FH and EH meet at one point. Since we have drawn in the second step for FH, now in the next step we have to draw for EH. So to draw this, we have to take E center and radius of the arc should be 4 cm. Step number 3. With ES center and radius 4 cm, another arc is drawn, cutting the previous arc at 8. So again, let's measure an arc of radius 4 cm 4 centimeter. Taking E as center, we cut the first arc at one point, and you can see two arcs intersect at one point, and this point is H. The next step number 4, HE and HF are joined. Now let's join them by using scale. Then next, now in our construction we got EF, EH and FH. Then we'll try to get FZ, EG and then HG for this. Now step number 5, with F as center and radius 4 cm and arc is drawn. While we have taken here 4 cm as radius, we are to draw for size FG. You know FG length is 4 cm. So now let's do this step number 5. And let's measure 4 cm radius, 4 cm. We take F center and then an arc whose radius is 4 cm is drawn. Then next will be, since we got for this FG, next will be for EG, whose length is 5 cm. For this we'll take E center and radius of the arc will be 5 cm. That is step number 6. With E as center and radius 5 cm, another arc is drawn cutting the previous arc at G. So let's measure an arc whose radius is 5 cm. Taking this E center, we cut the first arc at one point, and the point of intersection of two arcs is G. Then the last step, FG, EG and HG are joined. Let's join them. So this EFGH is the required quadrilateral, and you can verify the length of these three sides and also the length of these two diagonals. Therefore, EFGH is the required quadrilateral.